Hi and welcome back to a new video. I'm often hunting for bizarre and obscure hardware online to find them for my videos, and a couple of weeks ago I found this one. The Q-Tec water cooler P4 heat pipe. P4 stands for Pentium 4. Q-Tec is a brand from 2004, that's 22 years ago. And just when I was looking at this and reading the name, honestly, I didn't know what this is about, and I want to find out in today's video. The Seasonic PX 2200 is currently one of the strongest PSUs available, and it comes with two native PCIe 5.1 connectors, which allows to even hook up natively to RTX 5090. That is perfect for any overclocking system or high-end workstations. I'm also currently running this PSU, and so far I'm really satisfied with its quality and performance. The cables are very flexible, there are also cable comms included, and in addition also a 90-degree ATX 24-pin adapter, which also functions as a PSU tester at the same time. The fan is semi-passive, and even at a high load it is still very quiet. Find all information about this PSU in the link in the description. This unit is still in its original box, it's sealed, it's brand new, which I always find mind-blowing after 22 years, but it's always also a challenge after 22 years to find more information, to find what was this about, and also, for example, to just find reviews from back then. I can also tell you, when I was buying this, I was not looking for this specific unit. I was looking for a water cooler, and that's what I was looking for, and it has a water cooler in its name, but I'm not sure how it makes sense. As I said before, it says water cooler P4 heat pipe. If you look at the unit, it just looks like a, I don't know, like an air cooler with a big heat pipe in the center, or like a big copper rod. Could also be a solid copper rod. But then if you're reading on the bottom, the text underneath, I'm not sure if you can probably see it, but it says P4 CPU cooler with liquid filled copper heat pipe. And that's what's confusing me a little bit, to be fully honest. So did they take just a copper tube and fill it up with water? Because just for physics, that wouldn't make a lot of sense. Just from a physics standpoint, it wouldn't make sense to have a big rod or a tube in the center and fill it with water, because water has a great heat capacity. It can take a lot of heat, which is what you use in water cooling systems, but it has a very bad thermal conductivity, at least relative to, for example, a solid copper rod or even a heat pipe, which is even better. But a heat pipe relies on phase change, so you have a small amount of liquid inside, which evaporates and then condenses back, and you have like a cycling system. But yeah, I'm not sure if this is like wrong wording, wrong marketing, or if they were experimenting with something that just doesn't make sense. But it's hard to tell, because 22 years ago, just heat pipes were becoming a thing, and at that time also companies were doing a lot of crazy stuff and like bad stuff, right? But I could at least, with the link that's written on the package, which is qtec.info 14141, I could find this thing on archive.org. And there I could find the water cooler P4 heat pipe, which is advertised with the key feature liquid filled copper heat pipe and superb cooling capacity. There was not much more I could find out, because most of the other pages are not archived, but I could at least find out on the main page that Q-Tec stands for Quality Technology Computer Products. It's hard to tell how much quality there actually is inside the Q-Tec products. The only thing I can say is that the website went offline end of 2007, and I didn't hear anything from Q-Tec afterwards. I want to mount the water cooler P4 heat pipe on this setup, which is currently running a 9800X 3D with this NHD 15 that I still had mounted from my previous video. And I'm currently running Cinebench R23 and a 10-minute looped test. Power consumption, as you can see, is about 150 watts. The CPU reaches about 90 degrees Celsius and is clocking at about 5.1 gigahertz. Let's open this box and see what's inside. One thing I'm glad that changed over the past 22 years are those packagings, boxes. It used to be this big thing to put everything in those blister boxes, blister packaging, which is so annoying to open. I'm glad that we hardly find them these days. First impression, this is quite well made, especially for the time. Quality and finish look nice. It's odd that they used a 70mm fan. Even back then, this was an odd fan size. You would either have 60 or 80mm, but 70, not that common. We have a lot of aluminum fins, the big copper cylinder in the center that could be anything, like a heat pipe, like a solid copper block, we don't know. It's surrounded by a blue anodized aluminum case, Q-Tec logo on top. And if we turn it around, I'm sure we will find the contact patch underneath. and what was also included is this backplate. Just judging by the weight, I can definitely rule out that it's a solid piece of copper. I mean, that also wouldn't make sense just going by the text, the advertised text, but also having water inside just doesn't feel like it. We did this a couple of times before, that we adapted old blocks to mount them on recent systems. It depends what kind of socket is supported, but for this one with Pentium 4, it's not that easy to adapt this to AM5. I will definitely have to find a solution for that. I first removed the original screws, and now I'm thinking to use these AIO mounting brackets that I have left from another AIO to mount them on here, because I have the original holes and I can transfer them onto this and then probably just mount it. Got the holes inside, and now I want to mount it on the cooler. I think this should work. It's not perfect, it's overlapping here a bit more than I expected or intended, but it should be enough clearance, and I will just try to mount this one. Mounting worked exactly as I expected, so that's nice. And it's just mind-blowing if you look at the size of this cooler and compare it with anything that you have these days when it comes to air coolers. Like this was considered a high-end air cooler 22 years ago, and it's a fifth of the size what we currently have. And I just attached it to my bench table, and then we should be able to control fan speed. And now we will just power it on. Fan is definitely still working, just not in a super pleasant way, but it's working. I can definitely say that the cooler is working. It has contact for sure, because if we just simply check in Windows idle, of course there is not a high load, but still we are seeing about just 30 degrees Celsius in idle, which is a good indication that the contact is there. It is dissipating heat. We just don't know yet how much it's capable of, and that's what we will find out if we launch Cinebench. We will not straight do the 10 minutes test, but just one quick run and see what happens. We will again have about 150 watts load, and 95 degrees Celsius is really hot. We can see that the CPU is not capable of maintaining the 5.1 gigahertz. Yet we still get 21.6k points in R23, which is basically what a 9800X 3D is expected to achieve. But yeah, just a single run. We will see 10 minutes. Test has been running for over 5 minutes. It's still constantly hitting 95 degrees Celsius. It's not able to maintain the expected clock, has to downclock to about 4.7 to 4.8 gigahertz, but we see that it's still able to constantly dissipate about 130 watts. Going back in time, 2004, there was socket 478 with Pentium 4 Extreme Edition, and those CPUs would go up as high as 110 watts TDP. I'm pretty sure the CPU cooler was able to handle that, but not at a super nice temperature. Still, we can see it's working, but I'm still not sure what is exactly going on inside, and for that, I think we will just have to open it up. Contact was definitely great between the CPU and the cooler. You can also see that the contact patch is pretty much perfect for nowadays AM5 CPUs. First we want to remove the aluminum cover, and I think the fan will just go with it. There's not much to this cooler if we just remove the two base parts. Just a plastic cap that remains on top. I will also try to take that one off. That's also something I have not seen before. Just like some sort of sealant or glue that's on top of this copper rod. It's not super convenient to saw this way, but if there's fluid inside, I don't want it to leak out. We definitely punctured it, but so far there's no liquid. Well, there's no liquid inside. It's hard to tell, but you can see it all the way to the bottom. There's this type of sinter material that is covering the entire wall. What we're seeing in the end is a so-called heat column. That is close to a heat pipe in the way it works, just with the difference that the heat column itself is also having the direct point of contact to the heat source. Whereas a heat pipe, for example, is usually just transporting the heat between points. So you have like a contact patch of the CPU cooler that is connected to heat pipes, and then the heat pipes are connected to fins. And heat pipes are just more flexible. You can have multiple of them and you're not as limited. So this one is limiting your just overall heat dissipation by the one unit. And you're also limited in how you're transporting or distributing the heat within the cooler itself. Because it will always just spread from the center. Whereas if you have, for example, 6 different heat pipes, you can spread this just throughout a bigger volume and also, for example, towards 2 towers, as you could see with the Noctua cooler. But yeah, water cooler makes no sense. It's not a water cooler. I'm pretty sure if you would advertise this these days, you would probably get sued because this is not a water cooler, right? It's a heat pipe cooling solution. Of course, there would be some liquid inside, like 0.1 milliliters or anything like that, but this for sure cannot be called water cooling. I'm not sure why they called it water cooler, because maybe they didn't know how it works themselves. They maybe just sourced something in China and didn't know how it works, or they were just simply trying to be misleading. You might be surprised, but I assembled everything back together because I want to test what happens if the heat column is no longer working. Already in idle, you will be able to tell a big difference, because if you just check what is happening, you can see that the CPU is between 50 and 60 degrees Celsius without any kind of load. I think now it will be important to see how fast and quickly such an AMD CPU can react to downclock. Within seconds, we are hitting 95 degrees Celsius and the dissipated heat keeps dropping. After again 5 minutes, we can see it drop down to about 60 watts that are being dissipated, and that's only enough to run the CPU at about 3 gigahertz. Now that the cooler is open anyway, we can experiment further and simulate what would have happened if they made a real water cooler with a heat column being filled with water. I think we just add some water in there while it's running and see if this helps. This is definitely dangerous, so I will have to be careful. And we can see it's filled all the way up with water. At least initially this seems to help a little bit. But I think this is only because the water now can take quite some heat. What is super interesting is if we just look at the water, there is movement inside. Not only the rotation that we can see, but also some particles. I'm not sure if you can see it on camera, but there is a little bit of stuff that is floating up and down. It makes sense though if you think about just the temperature difference inside this thing. Like the bottom touching the CPU surely has 60, 70 degrees Celsius, and it's getting less the higher you go. And that's surely causing a movement inside the water. And again, after 5 minutes, we can see about 80 watts that are being dissipated. If you ever wondered what would happen if you open up your heat column and replace the inside with water, then this is what you're getting. You will still lose a lot of performance, but it's better than having nothing inside. And going back to Q-Tec and what they were advertising, I'm just not sure in the end if it was a pure marketing lie or if they simply didn't know what they were actually selling. I hope you enjoyed this video. See you next time. Bye bye.